Hello, Washington Liberty Chemistry students. This is your Unit 2 lesson on significant figures and calculations. So there are rules for significant figures in mathematical operations. And unfortunately, there are two rules. There's a different rule for addition and subtraction than there is for multiplication and division. So you'll need to learn two rules if you're going to be correctly deriving calculations and deriving units using significant figures correctly. So the first rule is for addition and subtraction. It says the number of decimal places in the result equals the number of decimal places in the least accurate measurement. So this one is pretty straightforward. We've talked about it before when we talked about averages, the fact that you can't take an average out any further than the decimal place of your measuring device. Here's an example though. So if for some reason you measured two different objects on two different scales, one which went to the tens place and one that went to the thousands place, and for some reason you wanted to add those two measurements to see what the result would be, you would end up with the result of 18.734 in your calculator. But in order to follow the rules of significant figures here for addition and subtraction, you have to round to the least number of decimal places. So since that is the tens place, you would have to look at round to the tens place. Now, you would need to see the whole number because you're going to have to decide whether or not you just drop this or if you round the tens place up. And since this is a 3, you just drop these hundreds and thousands place. If this had been a 5 or anything above a 5, you would be rounding up to 18.8. But since it's a 3, you do not round. So it would be 18.7 grams. And again, the number of decimal places in the result equals the number of decimal places in the least accurate measurement. Really think about that. This is an uncertain digit, so you really can't have anything beyond the uncertain digit of the least accurate measurement. So the least is the tenths place. So that's why we have it as our measurement that we would write down in our lab report would be 18.7 if we were adding these two masses. Okay, so let's just practice this. And again, I'm going to give you a calculation. I'm going to tell you what the calculator says. So you don't actually even have to have that in front of you. But then you're going to have to follow the rule to write the correct answer, which is rounded to the correct number of significant digits. So if you were to measure two lengths and want to add them together, 3.24 plus 7.0, your calculator would say this. But you have to look and decide that the least decimal place here is the tenths place. So I'm going to have to round this answer to the tenths place. Since this is a 4, I just drop it. And that would be 10.2 meters. Let's try another one. Okay, now it's a subtraction. Same rule. What's the least decimal place? We have tenths and we have hundredths. Now our calculator is going to say this because it doesn't know anything about significant figures. But we know from our rule that we have to round to the tenths place. So since there's a 7, we're going to have to round up. This is closer to 0.3 than 0.2. So you would get 76.3. Here's the next one. The first has to the hundreds place. This one is the thousands place. Our calculator says this, but our least decimal place is the hundreds place. So we're going to have to round to the hundreds place. Since this is a 1, we just drop it, and you would get 2.39. Next one. So we have this, we're doing a subtraction of liters. Notice this one goes to the tenths place. This one goes to the thousands place. So we're going to see that our calculator says this, but we have to round to the tenths place. So we just look at this number. We don't care about this number. We see the 2 here. So that means that we don't round up, that we're going to just drop this, and we'll get 709.2 liters. Here's another one where we are again at the tenths place. A lot of tenths place here. This is at the hundredths. You're going to get this. Now this time we've got a 7 here. So if we're rounding the tenths place, we've got to round up to 18.21.6 pounds. Okay, here's our next one. Let's see if we're tricky with this one. Notice this goes out to the thousands place, as does this. Our calculator, on the other hand, only goes out to the hundreds place because these were zeros. But we know from our measurements that we can go out to the thousands place, so we should have rounded and added that extra zero. See, our calculator doesn't know how to round for significant figures. All right, now that seems pretty straightforward. We're looking at decimal places. Now, you're probably wondering why in a previous lesson we learned how to count significant figures. And that's because of the rules for the mathematical operation of multiplication and division. Let's look at this. For multiplication and division, the number of significant figures in the result equals the number in the least number of significant figures in the measurement used in the calculation. Now that's a lot of words, so we're just going to look at some examples. But this is where we're going to have to use our counting. So we're actually going to count. We have 1, 2, 3 significant digits. Does not matter what the decimal place is. We've just got 1, 2, 3 significant digits. On this one, we have 1, 2 significant digits. So our calculator is going to say this. But since this only has 2 significant digits, and this has 3, the least number of significant digits of these two numbers is 2 significant digits. So we have to round to 2. This is 4. So we have to look here. That's a 7, and we'll round up to 13. So again, we're counting not decimal places, but how many digits. This one has 3. This one has 2. So therefore we have 13 as our rounded number. Note the units, by the way. Centimeters and centimeters would give us centimeters squared. This might be a measurement for area. Okay, so let's just get some practice here. Okay, here we go. We're doing another area. Our calculator says this. Now, this one only has 1, 2 significant digits. This one has 3. So we have to round this to 2 digits. Remember, we're not paying attention to decimal places, just digits. So it's 22.6. So that means we're going to have to round up to 23 meters squared. Okay, here's another one. This is a density calculation. We've got 4 significant figures here. 1, 2, 3, 4. This 0 is significant, this trailing 0, because it is after a decimal point. 1, 2, 3 here. Now our calculator says this, which is crazy. Look how long that is. But you can see the least number of digits we have is 3. So we're going to have to round to 3. That's 1, 2, 3. There's a 9 here. So we round to 4.22 grams per cubic centimeter. All right, now this one. This one only has 1 significant digit because these are placeholder leading zeros and they don't count. This has 4. Now our calculator says this, but we can only have 1. Now remember, these leading zeros don't count, so we're going to have this digit right here. The 7 rounds up, so our correct answer, correctly rounded, would be 0.05 cubic centimeters. Here's our next one. This is speed or velocity, meters per second. We're doing a division. This has 3 significant digits, 1, 2, 3. This trailing 0 is significant because there's a decimal in the number. Here, again, we have a trailing 0 that has a decimal in the number, so there are 2. Our calculator says this outrageous number, but we see that we can only have 2 digits if we're following the rules. So it's going to be 2.3, and then we're going to look at the 6 and realize we have to round up, and that'll be 2.4. Okay, let's look at this. This is foot-pounds, and you can see we have 1, 2, 3, 4, 5 here and 3 here. Our calculator says this, but we can only have 3. So that would be here. Now we're going to have to put a placeholder. So that's going to be 5,870. And again, the reason why this is a 0 is because we can only have 3 and we have to have a placeholder. Now we could put this as in scientific notation, and we could have had 5.87 times 10 to the third. But if we are going to use the 0 here, that's going to be our placeholder for the number that does not have a decimal. We have another division here. Again, we've got 1, 2, 3, 4. Sandwich 0 counts. Trailing after a decimal counts. We have 3 here. This would be our number, but we only have 3 digits, so it's going to be 1, 2, 3. And since there's an 8 here, we'll have to round up. 0.359. And that is your practice. Now you're going to do an exit ticket and do a lot of practice with this. Remember, there are two different rules. One for addition, where you look at decimal places, and one for multiplication and division, where you look at actual number of significant figures to determine where to round.